Watch this. Check which of the following schedules can appear under timestamp ordering protocol. Which means if we have timestamp ordering protocol, which are allowed? That is what they're asking. So here they didn't mention anything about Thomas Wright rule. So without Thomas Wright rule, we are supposed to solve this. See this. In this schedule, T1 is happening early, right? Which means T1's timestamp is less than T2, right? So if there are any conflicts between T1 and T2, T1's operation should first be done and then T2, right? Now see this. There is a conflict here. Here there is read B and there is write B, isn't it? There is a conflict. Now in this case of conflict, since T1's timestamp is less compared to T2, T1's operation should be done first. Yes. T1's operation is done first and then T2, right? And again, see this. Again, there is a conflict here, right? And in this conflict also, T1's operation is done first. Therefore, in both the conflicts, T1's operation is done first. And so they are legal according to the timestamp ordering protocol. And moreover, they are equivalent to the serial schedule T1 followed by T2, conflict equivalent, right? Now let's see the next one. This one. Read, write, read. And here also T1 is happening first. Therefore, timestamp of T1 is less than timestamp of T2. In case of any conflict between T1 and T2, T1's operation should exist first, should come first, and then T2's, right? Therefore, if you observe these two actions, read and write, there is a conflict here, right? So this conflict says that T1 should happen first. Yes, T1 is happening first and then T2. Now again there is a conflict between these two, right and right. But then according to in this conflict, T2's action is happening first, which is not allowed by timestamp ordering protocol. See, so timestamp ordering protocol says that this action should happen first and then this one, isn't it? This action should happen here and then this one should happen, right? But then it is clearly violating, right? So this is not allowed under timestamp ordering protocol. Got it? Next, look at the next example. See this. This is given. The statements are given. This is the schedule W1, W2, W3, W1, W2, W3 and R2 and R4 all are acting on X itself, the data item X. Consider the schedule, this one, and the statement 1 is, and the statements are like this. Statement 1, above statement is possible only under timestamp ordering protocol. Above schedule is possible above schedule is possible under Thomas Wright rule. So they are saying that this one is possible under Thomas Wright rule or timestamp. They have to find it out. So now that schedule is actually written in this table like this. If you are comfortable with this table, better go with this. Okay. Once you write down in the table, we got like this. So if you observe the order in which they are appearing, T1 has appeared first, and then T2, and then T3, and then T4. Therefore, the serial order in which you should follow or try to serialize them is 1, 2, 3, 4. In case of any conflicts, the conflict should be resolved by putting this order first, which means if there is a conflict between 1 and 2, 1's action should occur first and then 2's action. If there is a conflict between 2 and 4, 2's action should occur first and then 4 action, right? So if you see that everything is followed like that, then the schedule is timestamp ordering. Otherwise, we can apply the rule, Thomas Wright rule, and again we can check it. Okay, just watch this one. Now there is a conflict here, right? So what does this conflict say? T1 should be first and then T1. This one says that T1 should be first and then T2. Yes, here T1 is first and then T2. Fine. And again there is conflict here, right? This between 2 and 3, 2 should come first and then 3. And here it so happened that 2 is coming first and then 3, right? And again there is conflict between 2 and 3 again, but it is saying that 2 should come first and 3, but then it is violated, right? Therefore, this schedule is not possible according to this timestamp ordering protocol. Now we have to check if it is possible according to the Thomas Wright rule or not. See, this failed because of write-read conflict, isn't it? So Thomas Wright rule can save us only in write-write conflict. It cannot save us even in the write-read conflict, right? Therefore, this is definitely not timestamp ordering protocol, and this schedule is not possible under timestamp ordering protocol, or it is not possible under Thomas Wright rule. Got it? Now check this one, next one, this one. Watch it. So here T1 should be followed by T2. That should be the order, because that is the order in which they are appearing, right? So here there is T1 and then T2. Therefore, T1 should be followed by T2. In case of any conflicts, T1's action should occur first and then T2. So see this. There is a conflict here between these two operations, and in this conflict, T1's action has occurred first and then T2. Therefore, it is fine. And again, there is a conflict between these two. In this conflict, T2 is occurring first, which we should not allow according to timestamp ordering. Therefore, this schedule is not possible according to timestamp ordering, but this schedule is definitely possible in case of Thomas Wright rule, because Thomas Wright rule says that, see, this is the delayed write. It is supposed to happen first, isn't it? So even though you are this particular operation is supposed to happen first, the final write has to be done by this write, isn't it? So which means even if it had happened first, anyway this value will be replaced by whatever value is written by A. And one more thing, see, this is right, this has to be written here, and this is not reading it. Got it? So it is a kind of blind write. So in kind of blind writes only you can apply it, okay? Kind of it. So now when you pull it up, even though, see, what I mean to say is, even if it is there, anyway the final answer is going to be written by, the final output on A is going to be written by T2. Therefore, you can anyway neglect it. You can ignore this operation and let this transaction run in the schedule. Therefore, this transaction is allowed by just ignoring it. Got it? Okay. Let's look at the advantages and disadvantages of this timestamp ordering protocol. Advantages. This protocol ensures serializability. I told you that serializability is definitely guaranteed, and it is conflict equivalent to the serial schedule, which we get by ordering according to the timestamps. And then it ensures the freedom from deadlock. So there will be no deadlocks here because there are no locks at all. So there is no deadlock. And starvation may occur due to continuously getting aborted, which sometimes some transactions will continuously get aborted if they arrive late at any point, isn't it? If a transaction arrives at the beginning, then it is supposed to finish all its conflicting actions ahead of other transactions. In case if it gets late, it will again be restarted again. That is the reason a transaction might get aborted many times, and so there is a chance of starvation. Okay.